All right, so the difference on this one is that I wanted to start adding a forest element to the ground. So it's not just flat anymore, but we have these trees starting to show up in various clumps as the forests expand out and grow. And we see different sizes and shapes of trees and all this stuff. And it really didn't take much to build it. This was a fairly random choice as to what does it, but the stylization tends to work out fairly nicely. So I want to go out to scenes so we can kind of see how this gets built up. Got kind of a good distribution of items there. We can see it's starting to build out in this direction a little bit more. Anyway, but while that's going on, I want to talk a little bit about some of the changes that have happened in order to support this code. So let's pull up GitHub Desktop. It works. Simple, it's easy. And if I need other more complex behaviors than this handles, then I have other tools that I can use. Anyway, let's go on into here. And the first thing that changed is cube.cs. It used to just have vector3 int positioning, but we've added two other fields to it that are kind of important now, or have become important. So the first one is ID. The ID is used inside of Unity. So if I take a look at one of these grass clips, terrain elements over here, we see ID of 1. Now, if I click one of the ones from the forested area, then we get ID of 2. And that is so that we can have a way to quickly identify what type of IDs we're interacting with, what is associated with that cube. Now, in this case, I have code in here that is specifically checking that forests can overwrite empty space, and they can also overwrite other forest, and they can also overwrite grass tiles. So I wanted to have that information in there, so when I start adding things like water, the forest won't grow into the water. I wanted it to have very specific cases of what it can overlap. All right. So the cube has just that additional piece of information. It also had one other field in here, important reference, and that is so that I don't have to look up the, in this case, the forest block component. I can just cast the reference, the important reference as the forest cube, and I don't have to do a lookup then. So now let's dive a little further into the code because that forest block has a little bit of stuff going on in there too. So we have optional decorations. If I go into the terrain and I zoom down into here, we can see that it's got this forest in here. And each one of these forests, when I expand this one out, let's just expand this out, it's got a bunch of empty spaces here. If I take trunk 1 and enable that, we get this little tiny tree, like this one over here, or these little ones. And if I go to trunk 2, I get this larger one, or this medium one, I should say. Several over there, one over here, a couple here. And then finally, of course, is 3. So trunk 3, and that's it. This is really lightweight. This is just a few cubes put together. You can see it's just stretched and scaled cubes. Here's like 3 cubes put together to make this forest top. When it was all clumped together like this, it's got a very different appeal to it, different feel to it. And the stylization generally works. It's pretty easy to overthink a lot of the stuff that you want to do in game development, just to end up coming back and trying something simple and it end up looking pretty nice. All right, so anyway, all of these forest cubes have all of those potential options available at the beginning. Now, there are definitely going to be ways that we could optimize this and make it even better, but I'm not worried as much about optimization at this point. I still want to see things get built and generated. Okay, so I've added the items, but you can also see I've done another thing here where I've added trunk 1 3 times to this. So, and I've added trunk 2 2 times to this, and trunk 3, the largest one, 1 time to it. And that's because when we're in the code, it's just going to select one of those at random. Now, it also has a lower chance. So basically, if we select something below what the actual selection index is from the optional decorations, then we just don't put anything there. And it's how much are we randomly assigning the chance to just have an empty forest tile. Okay, so that helps us give us some negative space in there. And otherwise, then as long as we have one, then we set that optional decoration to active. And that's it. This is a really simple, lightweight script. There's not much to it. It's just all about the design elements. Okay, so next we have the bot. Oh wait, let me check to make sure I didn't have any other piece of code here that's important where I have something missing. Okay, so I put in two new functions. I added getCube and remove. So let's go check those out. That's in the cube system, and if I scroll down, we can see we have getCube, and that is literally just getting the cube, and if it doesn't have it, then it'll just return null. And otherwise remove where we are just removing. Again, we are not doing a check to see whether or not that exists in the dictionary first. We can just trust that it is. All right, so now let's see. The next part of this is the actual bot that's making these changes as we go. So I'm going to scroll up to the top. Which actually we're getting a lot of content here. We have like no chunking or anything going on to establish this. So this ground size is getting pretty large and still growing. I'm just going to put a pause to that for now. Okay, so now I've got the forest bot. So here's the forest bot. It's got a little bit more complications to it, but it's a smaller segment of code. It's fairly simple. So the prefab, we select that prefab cube. It's expecting the forest block. That's the type that it's going to be casting it as. We also have the chance to spawn a forest. How often? And that is a, 0.4% chance that it'll actually spawn it. Because remember, we have this, the grass is just continuously going back and forth. And a lot of times the pointer of it is right over any random given tile of grass. So we don't want this going off a lot. Then we're going to set the minimum size. So basically this is saying it'll always be at least this size, and then here's what the maximum is. So what we're doing right now is we're saying that for the forest minimum size, we can't put one in at all unless we have at least this amount of space free. But then for the current code, we're just going to stamp the whole thing down. All a radius of 5 outward from the center. Then we've got the ground bot, because we're actually using the ground bot's position, what it's paying attention to. We also have another thing just to define whether or not it's building. This is debug information, so I can put it back to private. And then what is the low tree chance? So the chance of not having trees added. If I were to decrease this number down to like -30, we would have very few trees show up at all. One other thing is that in this I've also added a few extra materials in here. So we have forest ground and forest leaves, which are basically the exact same thing, but I could make them different if I wanted. And then we have the trunk, which is just kind of this brown shade, and that's really all. Okay, so last part, let's go back into this forest bot and dive into the code a little bit further. So we saw it from the front end. Is building doesn't need to be public, so I'm going to make that private for now. Because that is something that I don't want us to accidentally click and get rid of while we're just watching it get built, because that'll break the entire bot from operating. It'll never exit properly. Or it'll exit early, even though it's still running, and trigger another instance of it, which I'm not even honestly sure what would happen, but that's kind of the point. I don't want it to happen. I haven't designed it to with anything in mind, and I don't want to figure it out right now. Okay, so anyway, during the update, we're going to check to see if we are building, or if the just some random value is greater than our chance to spawn the forest. Then we're just going to return. Or we're not going to try to spawn a forest here, because that's all our update is doing. It's just going to check and see if our 0.4% chance of spawning a forest will happen. So if we're already building, then no, we're not going to build it. And otherwise, if we are, if we can only do it when we get that value. All right, so next we have something in here. If has minimum space for forest. So I have a function that checks for the minimum space for the forest. And of course it's a not. So if it doesn't have the minimum space for the forest, then return. We're not going to try building it, even if we have passed the opportunity. So that's another point where we can just cut this out and the chance isn't 100% accurate. All right, it's actually a lower chance than what we have in here. Now, at this point, we've decided that we do have the space to build it. We had the we're setting up the chance. We aren't currently building. So now we're going to say that we are building, and we're going to start a coroutine to actually build at this point. Okay, let's go ahead and take a look first at the has minimum space for forest. I'm going to go to F12, and this is going to call on something else called in radius. I'm going to go down to in radius. So in radius is basically just saying, give me a center point and then tell me how far out. And I'm going to give you all the int vector 3s, or sorry, vector 3 ints with the X and Y location that are actually located within that circular space. I just want to get a list of it all. And since this is a radius that can change in this, I decided that I will have a function that executes this every time. So it's an IEnumerable, it runs every time. And anyway, yeah, so the first thing we're just doing we get our radius. What is our squared radius? Then we are taking the x, and that's going to be from negative radius to positive radius, and the z from negative radius to positive radius. And then we're just going to check basically a Pythagorean theorem for distance without getting the square root. So we're doing this in the squared version. But then we're just checking to see, are we within that? So if we are less than that space, then we are going to yield return, or less than that distance, then we are going to yield return this tile. So every tile within that circle of space gets sent back. There are more efficient ways that we can do this, particularly it's not like we have huge, massive radiuses. If we were just to have a collection of memory that's had the array already stored for 20 of these, for like everything from 5 to 25, for our radius, then that would work just fine. It probably would use less memory or less resources overall. Okay, so that is our in radius. And where was I just before this? Has minimum space for forest. So yeah, so we're checking to see if we have the minimum space for the forest, and we're going to check what is the ground bot's current position. And then we're going to say, what is the minimum size that we can use? So this is passing back the int vector 3, all those positions that we can use. And so this is already in world space. I don't have to add this as an offset to the position like I did with the previous grass. Okay, so inside of here, now we are getting the cube that is related to that. And I want to see if there are any reasons why I wouldn't want to do this. So first, I'm going to say if C is null, then there's no cube to actually manipulate here. So we can't put anything down here. We're also going to check to see if the ID is 1 or if the ID is 2. If we've got grass or we've got a tile, we're going to continue on. And sorry. The thing is that if we do have something, we pulled up this position and it's null, it has an ID of 1 or 2, we're going to return false, that we don't actually have the minimum space to build this. And so it's only when we've gone through all of these and every single one of the cubes that we did find within that region, they were not null, they had an ID of 1 or 2, and then we can build it. So that's how we get our true. Now we're going to move back another step, and that goes into build forest. So at this point, we have decided we have enough space to build one. We're going to start building one. F12. So now we're in the IEnumerator. So the first thing we're going to do is we're going to take the center position. We're just going to record that because we want to build around where we are right now, not what the ground bot is looking at. Okay, so now we're going to go through every vector 3 int position in radius from that center point to the forest's maximum size. And so for here, we're just going to instantiate a prefab for this right away. because we're going to put in a forest. We've already identified we want to put in a forest here. And I've also put in the ruling that if there is an existing forest element there, then we can remove that and replace it with this. So it's like we see the regrowth of a forest, the alterations and changes of it, so things can keep altering. All right. So now we have the forest. We are setting the tree in it, and we're passing in the low tree chance, the variable that we have for the bot, the forest bot, to basically set how likely it is that we'll have a tree or not. Okay, so we have our forest block. Now that forest block also has a cube in the same prefab. So we're getting the cube from it, and we're going to set its position because we have to set its position. And then we're going to say the cube instance. We're going to check the cube systems and see, does something already exist there? Remember, we've already checked the spaces at that beginning to see if it has it. And now, if something exists, we're going to remove it. Because also remember that radius is only the smallest radius. Now we're checking a larger radius. So we may be altering and editing things, and this might be something we'll have to come back to change as we have new things. But for right now, with just the ground and the forest combined together, it works. So if it already has something, we're going to remove it, and then we're going to add our cube to it instead. And once we have done that, once we have added something to it, we're going to yield return null. So basically that means that if we run through this, these for each statements, we're testing out all of these, and we're basically just going to replace every single one of them in that circle with a forest tile. But because of the fact, so this is just a circle. That's all it is. In fact, if I look at this, and it'll be easier if I look from here. See that? It's just a circle. Now, it's a circle at a fairly low resolution, so what is that, like 5 out? So you end up with this sphere here. That's as close to a sphere as this pixelation can get it. But when you're looking at the top, and you've got all of these clumps there, and you've got the forest kind of changing it out, one of the things that the coloring of the ground does in this case is it actually kind of makes it look like shadow, as opposed to just changes, differences in the texture. Where did everything just go? Oh, I'm upside down somehow. That was weird. Anyway, but it kind of makes it look like shadow, and I think that works pretty well. So when you're kind of seeing all these clumps happening all over the place, it works. At least I think it works well. It works for what I'm looking for. Okay, so anyway, that is how we are setting the position, or we're building the forest. That's how we're building the forest. That's all the code. That was 66 lines of code to get that one to work. And of course, this will also be committed in. I'm going to give the GitHub repo, but I'm also going to give the commit number that is related to this in the description. I hope you found this useful. Actually, there might be a couple things to discuss here that would be valuable to understand along the way. So I'm going to go back for a second, and inside of here. So again, I want to emphasize that this just used a simple circle, and every one of these are simple circles. But because of the fact that some of them get kind of clumped together, and then you're looking at this from a lot of these, it works really nicely. Now, when we actually come down to game design, there is a chance that we're going to make something very damaging. For instance, there might not be a pathway here. We're lucky. There appears to be pathway through this, but what if it's for like driving a tank or something? Then we can't get through there, so that doesn't work as well. And that might be something we'll have to change, where if it finds forest, it'll cut trees down or do whatever it needs to do to make it work for the design of that level. Change it out with grass tiles or stone or something else. All right, but we're not really worried about individual design yet for this. We will get there. All right, was there anything else with this? No, I think that is all. All right, yeah. Hope you found this useful. I'll talk to you later.